Okay, so for today's video, this will conclude kind of the threat mapping series that I started this week, right? But to conclude, I wanted to draw a reference architecture and bring your attention to how we're going to use this. So I put together this architecture to kind of go through areas that we'll start with, right? That we want to think about when we are adopting this type of technology. So we can see on the far left-hand side over here, if you can draw your attention to this direction over here, let me make sure. The Terraform side, we are going to deploy a GKE cluster. Now, this is just a reference. You could use Vault by HashiCorp or an external key management service, but ideally you want some key management service similar to Vault being used, right? And the reason being is because when we think about areas such as external secrets, we are going to want those stored outside of our cluster. Okay, so key concept here is here's an area that you could explore. Now, when we think about access, specifically for Terraform and GKE, we're going to need to have a service account, right? So, i.e. a service account. And we're also going to need this to have access to deploy our cluster, right? So we want to think about what is the level of access that we should grant for this specific storage account. Now, in the process of doing this tutorial, it took me quite some time to get around to fine-graining this, but specifically because GKE requires a good amount of permissions when you are deploying it. Right, so some key concepts we want to think about is we have our connections here as far as our IAM is essentially the service account that is acting on behalf of our Terraform code configuration. That is going to deploy a way to also access your cluster. Would do Cloud Identity Aware Proxy. This is a little bit more advanced than we're going to go into today specifically, but this is showing what a reference architecture would look like as the boundary before you enter the cluster's network. Right now, obviously, we want our cluster to be internally facing. For today's demonstration, I'm going to show a cluster I have up and running already, and we will switch over to what that looks like. Okay. In a second, but just want to draw your high level here. This is essentially the wrapper, right? GKE specifically. Now, when we think about areas that are points of presence per se, when we're threat modeling, we want to think about how are the ways we, as the blue team, right, would protect our areas of responsibility. So when we think about event threat detection, or broadly speaking, you'll hear this as agentless scanning, agent scanning, depending on what you use for a cloud native application protection platform. Natively, you can have this deployed as far as a security posture, security config through the Google Cloud Security Command Center, right, as a way to protect your cluster as well. And they do offer GKE Enterprise. So just to show you natively what this would break down to, right, ideally we have our cluster, think of this as our production, staging, and then obviously we have our separation of those environments, right? Two different networks firewalled across, right? We're going to have to use a network policy that we see here, right, to explicitly define our ingress egress routes. And then we also want to ensure that if these pods are supposed to be communicating with each other, specifically, how are we going to segment that? Most of the time this is accomplished with a network policy, right? Now, depending on your CNI, you could use Calico, which I'm going to be using today. I don't believe I have a logo for them here, but a large player in this space would be tools like Cilium as well, right? That offers eBPF as well, and some of those native protections. So we're going to switch over, and I'm going to show you kind of operationally what this looks like in the environment. So let me do a double take. Okay. Specifically, we should be seeing our node here. Now, for this specifically, the reason why I'm going inside this area is to show you where, A, what I have deployed, but B, what are kind of the configurations you need to be aware of to protect this platform, right? So what we're seeing here is we have a Kubernetes cluster. We have our one particularly running 1.27. Now, I ran into an issue when I deployed this with Terraform. I didn't put the node autoscaler, I left it as manual, so as you can see, I have exhausted some resources up here fairly quickly. So without further ado, I'll show you what an overview looks like in the console. So now you see down here specifically, and I'll put this up so the screen encompasses this. So you should also be seeing specifically a kubescape protocol ran, right? Or essentially running a kubescape scan. So without boring you specifically on all the details going on here, showing at the top when I did execute the scan, this essentially loads regular expression policies. It applies it to the cluster, essentially a validation check, right? And then this gives you the output. So this is known, similarly, we call this posture management, right? So we can see our secrets. We have no resources here that were found violating that. Anything that we see with a number oriented, that's the finding specifically, right? And then it also has a reference to those areas. You can also do high stakes workloads, essentially areas that are defined, such as the daemon set. This is going to look at the namespace in your kube system specifically. Think about that as the underlying components, why they are labeled high stakes. So now we can see out of the box, right? Just based on my configuration, I have a fairly somewhat secure area. As far as compliance, 81%, but I always say compliance doesn't always equal security, right? This is one way to measure. Now you can see here they also have other frameworks such as kubescape scan framework, MITRE, and NSA. Now I'm going to minimize this. And what I'm going to show specifically is out of the box what I essentially deployed. So a best practice when you're deploying this through Terraform would be to separate specifically your cluster creation from your actual node pool. The reason being is if you have to delete your cluster that was created with your node pool, essentially attached to the cluster resource itself, it is going to have to require the whole cluster being deleted in that regard. So if you want to get the best of both worlds, you want to segment these apart just at a high level, right? Now we can see here the networking specifically, we're going to have this defined as enabled, right? Now global access, think about this as a controlled access, you can edit this. I have yet to mess with that specifically, so I won't dive too deep into that. But I'd imagine it's essentially an identity aware proxy in front of it, okay? Now we can see here, I can go to service mesh, and as you can see, security posture, it won't, it has now changed. Previously, this used to be a part of the native console, but you can also see this will tell me of any posture concerns, right? So from a native perspective, you have quite a lot out of the box with GKE. They make it fairly simple. And then they also provide pretty much resources for any type of need for a service, right? So I can see here, relevant security bulletins, right? There's certain patches available, and it looks like I am affected by that. So let me see all relevant. And we can get some quick info on this. Okay, wait, no, it says my workloads are not affected. Or perhaps they are. Okay, so it looks like a control plane, change channel or upgrade. Okay, so I'm not going to do this right now, just so I can have access to my control plane, but this does make you aware if something is going on. I would start first with understanding A, your protocols and configuration before you deploy, and then B, you want to look at this as ongoing from a governance perspective, right? What should I be aware of from my supply chain, right? When we think about the node image itself, any vulnerabilities that do arise or exist. Think of this as your area that you want to focus on. Now, if we enable the policy controller, it's more than likely I have to investigate this further, but I'd like to say this is OPA gatekeeper. I'm going to enable it, see if it doesn't take too long, and then we can see kind of what's that aspect of it. Okay, one without the policy controller. So yes, similar. It's going to tell you if you're complying with industry standards, right? I'd imagine this is probably a managed service policy controller, so it's likely using gatekeeper, and it says I have to try. So we'll leave that for now. I know before I've covered the configuration area. Not much has changed in this space. You can see top cluster issues. I have, if I did have any areas here, I'd have synchronization, Prometheus, Cert Manager, GitLab. I think this is just showing parts of a specific example. Let me see if these actually affect me. Okay, no, this is all a part of their config sync. So I'm noticing right here, these have changed to enterprise. And before these weren't, I know I've done a video before, these things change pretty rapidly. So when we talked about earlier in the secrets phase, right, we want to think about our cluster. And where are our secrets, right? Secrets respects access controls and are not visible. So we can see that I probably don't have specific permissions on this set identity to open this. Now let's actually access it as the cluster administrator. Let's see here. So let me clear out our screen. We'll do kubectl, get secrets. Okay, so we do see we have out of the box some secrets in here. Now, when we notice the type opaque, right, think about the type of the secret itself, right? And then the data itself, essentially there's something there, right? So if I did kubectl describe secrets, and I did the namespace GMP system, we can do alert manager. So it looks like there is a config.yaml. Okay. But if you can see here, the alert manager itself, I did run a Prometheus, manage Prometheus on here specifically so I can view the secrets. As you can see, that is the difference of the visual and the command line. Now, if I go to monitoring, we can probably see what is going on in our control plane, right, a little bit further, so you can kind of see that logging aspect. So remember, when we reference back to the control plane itself, that is going to house a lot of our operations, and that's one of the areas when we think about visibility of logs. So whether you're using Fluentd, the daemon set, etc., those are going to be key areas that you want to have an eye on, right? Now, if I go to, let me just get out of this dashboard builder and all this other stuff. So it looks like getting started, Google Monitor, install agent. Okay, so let's go to GKE. And it looks like they're trying to push, well, it appears, at least from the dashboards, that they already have some pre-configured dashboards. So that's kind of neat. That you want to think about that as anything that is kind of out of the box, it's less work for you, building it on your own. But it's also a good starting point. If you can see here, I can add filters, etc. So this looks like this puts together a visual that represents your entire cluster, a part of that dashboard, right? So I can look at specific namespaces. I can look at, for instance, it's likely your operations team, SRE team, needs to be aware from their perspective, are we meeting SLAs, uptime in general? How's that kind of defined? We want to make sure that we're measuring this specifically. So this goes back to the auditing area. We can see here, we have some more pods, nothing to no active alerts, which is good for us. And so let me see if I can correlate some stuff with my desktop's moving a little slow on this view. And what I'll do in the meantime is let's switch back over. I want to make sure I'm able to sketch out specifically the areas that we need to be concerned about from the threat perspective. So drawing back to, let me grab my little tab, my pen over here. When we think about areas to worry about, right? And strictly speaking, we're going to think about it from the risk perspective, right? So we have our billing that we need to be responsible for financial ops. We have our access into the cluster itself, right? So the cluster access. Now we saw specifically that we defined at the network level, right? It's not a private network, but what I did was I circumvented that with authorized IP. Right, so essentially my home network, my public IP is just related to /32 as far as that authorized range. Now that is one way, but a more secure way would be segmenting the control plane to a private cluster altogether, or private network, and then accessing that through similarly a bastion of some sorts. So when we're thinking about GKE broadly, right, the areas that we need to be concerned about when we're using IAC is specifically the credentials of the service account. This is going to be huge because the permissions to provision a GKE cluster are a little permissive. So one of the key areas I would consider is either a just-in-time type of approach, right, for each cluster creation, but this could be a little bit cumbersome, right? Essentially, you provision the cluster through a templatized type of workload parameter, and then get rid of the service account upon creation. However, then you might run into issues long-term on the state file, perhaps not matching up, things like that. Those are some of the areas you want to start thinking about broadly, because the rubber is going to meet the road when you're managing this at scale, right? This is just one example, but not the only. So we notice that we're going to block our API access, right? And you want to think about that's going to listen on 6443. Now, if we block this, we're still going to need an entrance in. So most of the way that you can go around this or have another implementation, if you don't want to be cloud native in that space or from the provider, is you could use tools like Paralysis, right? And I covered this before, but this essentially creates a proxy through a private DNS A record, and this will look like a console dot whichever that domain is, .com, and this will allow your kubeconfig to be stored in an online portal, essentially, in a more zero trust mechanism. It has SSO, you can do MFA, things like that. Now, or you could go with the traditional RBAC. So you have options. Now, the reason why you see specifically out here external secrets, right? Now, broadly, we want to think about if that cluster was compromised, right, in any shape or form, the underlying key management system is away from the cluster itself, right? Now, the reason being is because if I can pull from a key management system such as Vault, from HashiCorp, Azure Key Management Service, Google KMS, right, whatever the case may be, we still have to house our secrets, but that also poses another resource that we need to put a protection layer around as well, right? So when we think about that, this is going to be a number of areas that we're going to have to deal with. Now let me clean this up a little bit, so not looking too mangy out here. Okay, I'll leave that there, Jim, so I don't erase my little bubble there. Okay, so these are the top line level areas that you need to be concerned about. Now, broadly, we're going to have to think auth and authz, right? And if we do authz, we're going to have to consider what is our back approach, right? Is it going to be, segmented? Is it going to be handled by the CSP itself, right? And then broadly, we're going to need our policies, right? And our policies are going to be defined in a number of ways. You can use OPA gatekeeper, right, which is native. Most CSPs will have this a part of their offering, right? Or you can think about, let me move over a little bit. Or you can use something else managed, like you could use a Kubernetes, right? Or their managed SaaS on that, a number of tools for the policy. So I'd say at a high level, we need to understand who can access the cluster, right? Who needs to access the cluster, and how can we control that access, right? These are our first questions we need to start with. Now, we ideally have all of this beforehand provisioning, okay? So I'm not saying to go provision a cluster, but these are the high level areas because the risk will live high, right? So risk itself will be slightly elevated here if we don't have visibility. And I don't suggest you not having visibility. So what are the tools typically to use for this? You could use tools like Trivy, right? By Aqua. You could use kubescape is a great tool that I use by ARMO. Another way, thinking broadly, is also the CNI and the decisions on what CNI you're going to use are pivotal. Why? Well, because IP address management, right, broadly, is pretty chaotic if you don't use something like Calico or someone else, such as like Cilium, okay? And most of the time, the Q proxy is not going to satisfy all your needs per se. So first we have to think about what are our defenses, right? And that's going to fall into, we're also going to need to consider our logging, right? In Google specifically, GKE, there is a way to have this segmented down to specific namespaces, and every cloud service provider has this, right? So this is not just limited to Google, right? This is broadly, this could be AKS, right? This could be EKS, wherever you want your workloads to live. So I'm sorry for my sloppy handwriting. I'm still getting used to using a pencil on this tablet here. And then when we think about up here, right? What are we losing when we go from managed to unmanaged, right? We want to think about, we don't have to worry about upgrade. Well, we still have to worry about upgrades, but it's much more manageable. Some of the backups are native to the provider or becoming more native. AKS does this. Typically, some people use Valero or something outbound for some stateful workloads. But what we're going to lose perhaps could be, depending on your CSP, is your upstream updates, right? And what I mean is every CSP will have a specific 1.29, let's say 0, right? Some are in preview, right? And then some are actually already out. It is supported by the provider itself, right? And then you can take advantage of all the upstream API resources. Now, I always say if you're starting out, right, let me clear some of this stuff. Let me move over here. let's say your organization, right? And I'm just writing this out, wants to adopt, right? Let's say GKE or whatever the case may be, AKS, you name it. You're going to have to consider what are the trade-offs, right, from a CSP approach for managed, unmanaged, right? So you kind of want to have a pros and cons. Now, the reason I like managed, right, is plainly, this is going to help you. Easier adoption. And a lot of the management is abstracted, meaning you will have upstream releases, right? You'll have updates for specific. This is a big one. Updates or upgrades are more seamless, and essentially the technical depth that your team must possess is, I wouldn't say less. But these are things that I would suggest, at least from the high level, right? So what do you get from managed? What do you get from unmanaged, right? I suggest putting a list out there. And then if you had to think about unmanaged, right? Let me move my cursor because my screen, there we go. So if we do unmanaged, we have to think about, and I'm just going to label this so everyone's on the same page. We could use kubeatom, right? We could use kubeatom. We could use K3s, right? We could use, some people will even use KOps as well as a production grade. Some people will use Talos. There's a number out there. But essentially, you have more control on the unmanaged side for the specific control plane. You are managing quite a lot, though. So when we think about your upgrades, right? kubeatom, I would say, is probably the most, outside of KOps, probably seamless. Seamless in the fact that a lot of it is still pretty straightforward, but you would have to, similarly, you can go up to, let's say you're on 1.28 just for simplicity, and you can go to 1.29, right? Now, I couldn't skip, let's say once we do get to 1.320, right, probably sometime this year, can't happen, all right? It's just, it won't. And the reason being is it follows the semantic way of updating by a version number. The reason why you win this over here from the threat perspective is for a number of ways. The provider, right, in this case, we can put provider, is managing the underlying node. And regardless of how you deploy that, you want to think of it similar to a PaaS service, right? We have access to the underlying OS. However, the management of that underlying OS is still the CSP's objective, okay? And that's why we pay them, right? We don't want to deal with the data center. We don't want to deal with all the other stuff. We just want our workloads to be running, take advantage of the CSP and cloud computing, right? Now, there's a whole lot more to that discussion, okay? And I'm pretty sure I just touched the surface. Now, secondly, when we think about what we should do, right, from a standpoint of, okay, what does day 2 consist of? We've adopted our cluster, right? So day 2, what are considerations? We want to think about broadly, do we have a specific, what is known as paved roads? And this is essentially, at least in my concept, are we on track in the sense of a goal, right? Whether our access is fine-grained, right? We know the workload specifically, we know our layout from topology of specific namespaces, right, that are going to be used for certain operations. And then we also got to think about cluster management, right? And the reason why you're starting to see this pop up more is because you're not just having one cluster anymore. This is groupings of clusters, right? So when we think about how many clusters, this could be broadly this could be 30, this could be 100 clusters, this could be a number. But how can we scale these clusters efficiently? And that's going to go into orchestration broadly, right? Because obviously when Kubernetes first came out, we were solving essentially the containers being, constantly treated like cattle, deleted, re-uploaded, things of that nature. Now we're abstracting to how are we managing groups of Kubernetes, right? Beyond just one or two clusters, but let's say organization-wide, right? You might have finance, you might have other departments whose workloads reside on that. That's how you want to kind of think about it. So there's a couple of areas you could explore here, and the complexities could be, fleet, or what is known as fleet management, that GKE does. You could also use a tool like Anthos. You could use Capsule. You could use a number, right? Now, when I talk about the paved roads, I'll go back to that first before I go another direction here. Paved roads is a goal of fine RBAC access, finely grained. Essentially, our namespaces are defined. We know who is essentially roles, cluster roles, things of that nature, but we have a good grip on managing that, access of that, and the governance broadly. Okay, so those are the top two that when I think about. Now, there's much more to this as well. We want to think about network policies, right? These are starting to get much more simplified, specifically with tools like Cilium, right? Tools like Calico. We could do cluster-wide policies instead of individually pod by pod, right? Cluster-wide policies is the way we want to think about. And then we also need to think about ongoing, what we call, our SBOM, right? Our supply chain for our cluster, right? We have to make sure that we're not as even hosting the cluster underneath any type of wrapper or type of vulnerability per se. But we also want to make sure that this is automated with minimal disruption, right? And we need context. Sorry for how sloppy this is looking. I'm trying to make sure that this comes out better. Okay. And then we also need to consider ongoing operations, right? What does that really look like for us? We understand that RBAC plays a pivotal role, right? We understand that it can be highly permissive. So we want to ensure that we have the minimal amount of people that access our cluster. And those that do, we need to ensure are needed, particularly are either viewer, right, in the context of Google's cloud, but we also want to ensure logging is configured for this specifically, right? And then we also know that network policies are a focal point, okay? And the reason I say this is because you should be out of the box blocking access to IMDS, right? And I covered this in the past video. So you want to think about this if you're going to go the managed route, right? You're still going to have instance metadata that is going to go outbound. And you want to think about this too, even if it's a private cluster. It's still going to send some type of IMDS data. So you need this blocked out, right? Then we also need to consider our pod-to-pod interactions, right? Our namespaces specifically. But broadly, we're going to need to first understand the context of what our threats are, right? We talked about access control being a high area there. Now, we also go into some of the image security, workload, infrastructure security, right? Some of those other things that we broadly define. Now, we also have to understand, and this is going to be really dependent on how we make our decisions upon creation, right? If we go with traditional RBAC, we are still going to be governed by clusters, cluster roles, and roles per se. But if we go the managed route, right, and I'm just drawing this here, if we go the managed route of using the native CSP, right, I'm just going to use Azure for this example. If we're going to use Azure, right, we could opt for Azure RBAC roles. And the reason why you would make this design decision, A, it's a good practice, right? But B, I can have the enforcement of conditional access, right? Similarly, constraints, I believe it's called constraint or conditional access as well in GKE. We can also issue out constraints for the same service account listed up here, right? If we can anticipate that this service account is going to be used for creation of this cluster, and we only want it for this specific cluster, we can define certain properties such as, and I'm just going to move up here so it covers that. We can define conditions on a service account. Think about this as limiting the exposure, such as time, that is access, and our expiration, right? Now, this is at a high level, okay? This can be as granular as you want to go, right? And I'm a huge fan of using custom roles rather than broad roles, because similarly, our custom roles allow us, the architects, more control, right? And if we have more control over the said role, or more granular in that realm, it's just a better practice to limit that access. So key concept, because I know I went a lot of places there, is if you are going to think about moving to Kubernetes, specifically GKE, right, you have a lot of design decisions to do, right? B, you also have to wonder about, what is the overarching end state of the defined infrastructure if you're going to use infrastructure as code, because of the way it's provisioned, right? It's not to say you can't manage it, but you will have to have some elevated service account privileges out there, right? It's the same thing across AWS, AKS as well, either service principal authentication, however you want to chalk it up. App ID, they have to have underlying permissions. Okay, so I don't want to lose that. But key concept, access controls, policies, how those policies interact, and then bringing it back to what are the trade-offs, right? From going from managed to unmanaged, and then specifically when we think about day two operations, right? Well, I hope this helped out, and I will put any resources I have available inside the chat. Thank you for your time.